All right, let's talk a little bit about L'Hopital's rule. Now, L'Hopital's rule deals specifically with indeterminate forms. Net form. So, what's an indeterminate form, you might say? Well, we've actually gone over a few of them before in the book um, when we were doing limits. So, that's if you have anything, maybe you're taking a limit, and L'Hopital's rule deals specifically with rational functions, but if you're taking a limit as something, is going to approach 0 over 0, or let's say infinity over infinity. These are indeterminate forms because we don't necessarily know exactly how this is going to behave in these instances. And there's a lot of other indeterminate forms out there. You can have it, infinity minus infinity, or 1 to the power of infinity, or 0 to infinity. Let's see, I guess the infinity to the 0. Uh, so when we talk about indeterminate forms, that's specifically what we're discussing. Ones that you can't just look at it and algebraically find the limit. So with L'Hopital's rule, so we have two specific instances that we can use it, or two, really just two ones that it's limited to this. If it doesn't meet either one of these criteria, one or the other, then we can't use it. So the first one is, so we're going to have two functions. So if the limit as x approaches a of f of x equals the limit as x approaches a of g of x equals 0. All right, so if this is the case, if this limit approaches 0 and this limit approaches 0, then you can use it. And the second case, if that one's not met, then if the limit as x approaches a f of x equals plus and minus infinity, and the limit as x approaches a equals plus and minus infinity. So you have to have one of these two met. If you have both, or one of these, I guess it couldn't be both. If you have one of or two of them met, then you know that the limit as x approaches a of f of x over g of x equals the limit of as x approaches a of f prime of x over g prime of x. So we're just pretty much taking derivatives on this one. So let's take a look at one really quick example that I think is kind of neat, and it's sort of nifty how it works out, because you can use L'Hopital's rule multiple times within one single within one single go. So here's our example. So first, taking a limit as x approaches 0 of x minus sine x over x cubed. Now, looking at this, you say, oh, okay, well, here, over here, you might not have to write this down, but just for your information, recall that the sine of 0 equals 0. And just for later on, cosine of 0 equals 1. So just kind of keep that in mind. So looking at this, we're looking at x as x approaches 0. So we have, all right, this first condition is met because if x is 0, you have 0 minus 0. So that's 0 over 0 cubed. So, all right, the temptation would be then to say, oh, well, obviously, this is going to be 0. But let's graph this real fast. So we've got x minus sine of x all divided by x cubed. There we go. All right, so we can see, we can see that that's not the case. That it does in fact. Here, there we go. All right, so we can see that it does in fact cross this axis. As it approaches 0, it is not 0, but it's some value besides that. So this gives us a way to figure out what that value is. So let's go ahead and have at it. So I know that this is 0 minus 0, so both of these equal 0, so my first condition is met. So that means I can take the derivative. So, oops, let me switch back. Here we go. So if I take the derivative, got the limit of as x approaches 0. All right, so derivative of x is just 1. The derivative of sine is cosine all over, then I've got 3x squared. All right, well, looking at this, I say, well, it looks like I'm stuck again, right? Because I've got the top, which remember cosine of 0 is 1. So I've got 1 minus 1, so that's 0. Then I've got 3 times 0 squared, so that's 0 over 0. So, bummer. Well, but have no fear, because since it's 0 over 0, that means that I can take the derivative again. So, here, let's see. I'll just do... So here we took the derivative to get to that one. So now I'm going to do it again. Take the derivative again. And let me scroll this down just a little bit. Alright, so limit as x approaches 0. Okay, the derivative of 1 is 0. The derivative of negative cosine is positive sine. And then the derivative of 3x squared, that's just going to give me 6x. Alright, well, shucks. It's still the same problem that we have. I've got sine of x up here, sine of 0 is going to be 0. So I've got 0 over 0. But good news, the first condition up here is still met. So I met the condition here, I met the condition here, and here again. So I can use L'Hopital's rule again. So I'm going to do this one more time. So I'm going to take the derivative. And so in this case, the limit as x approaches 0. Alright, so the derivative of sine x is just cosine x. And then the derivative of 6x is 6. And now we're in business because we're doing it as x approaches 0. So we're going to have cosine of x, well that just equals 1 over 6. And that's our answer. So you can see sometimes you have to take it multiple times, but if you do that, and even before you do anything, the one thing that you do have to check is that either this one is met or this one is met. If one of those aren't met, then the math doesn't really work out. So that's kind of a general introduction to L'Hopital's rule. A lot of times when you're doing these, it can benefit you a lot to do a little bit of algebra beforehand to help simplify it or get it into a form that'll be easier to work with. So just kind of remember that as you dive into the homework, but hopefully this will give you a good start on it.